Any questions over the homework?
13. Can we do
13?
13?
Yeah. So, looking at this here, problem number 13. Given angle GFH is congruent to angle GHF. Prove that EFG and GHF are supplementary. So EFG and GHF, for them to be supplementary, it means they need to do what? Add up to be? 180. So one of our statements, our last statement in this here, so it's going to take a few, 7, is going to be that they're supplementary, yes? So the one before it or somewhere above it, we need to show that those two angles add together to be 180. But the first place we can start off with is the given information. Is that GHF is congruent to GHF. So GFH is congruent to GHF. So EFG, we're wanting to show that this angle here is supplementary to GHF. We're wanting to show that these two angles add up to be 180, yes? And we know, so that's what we want to show. Now we know that angle GFH is congruent to GHF. These two angles are congruent to each other. Okay. Well, if we know that these two angles are congruent, we know that their measures are going to be the same. So the second thing we can say is that their measures are the same. Well, the reason we know their measures are the same is the definition of congruent angles. Now, we can't take that any further, because if two angles are congruent, it means they're equal, yes? Well, that's as far as we can take that. But now we need to talk about something dealing with supplementary, adding that together to be 180, yes? Now, to get there, what we can say is EFG and GFH form a linear pair. Because two angles that form a linear pair make a straight line. Because two angles are a linear pair if they share a common vertex inside, but no common interior angles. We can say this is given to us because it's in the figure. Because at the end of chapter 1 or in chapter 1, we said if 3 points are on a line, we can say that they make a straight line. And from that information, we can really just see that EFG and GFH do make a linear pair. They make a straight line. That's just from the figure. Now, it does work out if they are a linear pair. They add up to 180. I have a feeling we're going to go one step in between that and say that they're supplementary. Come on. Which means they add up to be 180. So we're going to fill up all of them because so far we've just said those two angles that are next to each other add up to be 180. Yeah. Because for most parts, especially if y'all were doing this on your own, I would have accepted going from 3 to 5 because we know that's true. Now, we're wanting to get where? That EFG and GHF are supplementary, yes? EFG we have, but here we have GFH. But we said GFH is what? Equal to? So GFH is equal to GHF. So we can substitute that in, because that gets us closer to where we want to go. Because what we're wanting, I'm going to scroll back up, I'll scroll back down. EFG and GHF are supplementary, so we want to be able to say that the measure of angle EFG plus the measure of angle GHF is 180. That's where we want to get to, because if we can say this, then we can say the two angles are supplementary. Now this spot number 5, we have EFG. We do have that part, but the other one is GFH. We want it to be GHF. We want the different angle. And now that we have that, we can say that they are supplementary. So this one here is a little bit tricky. Any questions on this here? We good with this one here? No, you're good. Do you have this? So the reference sheet has all our propositions, postulates, theorems, everything we've gone over. And a lot of what we're doing for these here is we're using those postulates, theorems, definitions that we've learned to prove what we're wanting. Kind of explaining why we can do what we're doing. We can look at that here in a second. And I definitely need to redo these slides. Because that's definitely a little grainy. The picture. That's a little pixelated. Or like my first cell phone camera.
What was it?
I could take 3 megapixel pictures that were black and white only. But the battery life was good. I think I could last about a week without charging it. Mm-hmm.
Did you have a flip one?
Little flip phone.
Is it a flip phone or the razor?
No. But now or then?
Now.
An iPhone.
Word.
But the main thing I used it for back then was to make calls. But that was it. I couldn't do anything else. We good for this one here?
Yeah.
You're welcome. So let's look at 14. Given segment AB is congruent to FG, and line BF bisects AC and DG. Prove that BC is congruent to DF. So with anything, we always start with the given information. So AB is congruent to FG. Okay. What else were we told? That line BF bisects line segment AC and DG. Always start with the given. We always want to start with the given information. Now what we want to get to is that BC is congruent to DF. We want to show that these two here are the same. That's where we want to get to. So our last line on the statement side should be this here. That's where we should finish. So these are the statements we have so far. Now, we have that AB is congruent to FG, yes? Okay, well, we're going to go a different route. Now, eventually, we're going to say that they are, we could say that they're equal. That is one route we can go. Now, one of the things we did get yesterday was our congruency statements, yes? Because here, we're talking about bisect, yes? So we know that E, DF, and FG are going to be congruent because it bisects, it cut them in half. We also know that AB and BC are going to be bisected. They're going to be cut in half. So what we can say is that BC is congruent to AB, and FG is congruent to DF. And we know this because of what? Because we said BF did what? It bisected it, yes? So the reason we know they're congruent is of definition of segment bisector. Because the definition of a segment bisector is it cuts a segment in half. So we can say that those two are congruent. Well, what do we know about AB and FG? They're congruent to each other, yes? So what can we say about BC and DF? That BC is congruent to FG. Yeah, so BC is congruent to FG. So we're going one step at a time. So we took this whole statement and this whole statement and put them together, yes? What property stated that I can take two statements and make them into a new one? Not distributive. Transitive. Transitive property of what? Segment congruency. Because we took two statements and made it into a new one, so it's our transitive property. And since we're dealing with segments and congruency, it's going to be segment congruency. Well, are we to the statement we need? Well, now we can make our final statement, yes? Because now I'm taking this one and this one. So we're taking two more statements, combining them into one, so it would be transitive property of segment congruence. So we're using it again. And some proofs are a little bit more straightforward than others. I think the reason that 13 was more confusing than this one is because we're dealing with all those angles, all the letters with the angles, and they overlap each other a little too much. Questions on this here? Yes. 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 5 through 10, 13 to 14. You're welcome. Yep. 2.3. 2.4 is on page 88, 3 through 13 odd, 26 through 40 even. Mm-hmm. Yes. Yes. You're welcome. Thank you. Any other questions on this here? All right, let's go on and look at the note sheet for today. Congruent supplements theorem. If two angles are supplement to the same angle or to congruent angles, then they are congruent. So if two angles are supplement to the same angle, or the congruent angles are the same, so we're talking about 90, then they are congruent. So what that's saying, so here, angle 1 and angle 2 are supplement. They add together to be 180. So we're going to say that they are. Thank you. Now we're also going to say that 2 and 3 are supplementary angles. They add together to be 180, yes? So according to this theorem, since 1 and 2 add together to be 180, and 3 and 2 add together to be 180, it means that angles 1 and 3 have to be congruent. They have to be the same. Now, congruent complements theorem. If two angles are complementary to the same angle, and to the same angle or to congruent angles, then they are congruent. So if 4 and 5 add together to be 90, and 5 and 6 add together to be 90, then 4 and 6 have to be the same. Mm-hmm. Questions on this here? So it gives the following. So this is our other type of proof that we can have. This is a flowchart proof. So it's at the bottom of that first page. Now the reason they call this a flowchart proof is, well, if you see here, this is a flowchart. It's going from one to the next to the next. And in a flowchart proof, we give our reasoning kind of next to the arrow or under the bubbles, just showing why we can say what we can. Now with the flowchart proof, just like with our two-column proof, we always start with what? The given. We always start with the given. And what is the given? Angles 1 and 2 are? Mm-hmm. And we know that because it is given. Yes.
Somebody's banging on the door. Somebody
Okay. Yeah, so the first thing we're given is that angle 1 and angle 2 are right angles. Well, if it's a right angle, we know its measure is what? So we can say measure of angle 1 is equal to 90, and the measure of angle 2 is 90. That's just the definition of a right angle. Now, where are we wanting to get to? We want to get to that angle 1 is congruent to angle 2, yes? So our last statement should be that angle 1 is congruent to angle 2. So transitive property, what did it do? It took two statements and made a new one, yes? So our statement before says the measure of angle 1 is 90, and the measure of angle 2 is. So So the measure of angle 1 is equal to the measure of angle 2, because 1 and 2 are equal to the same measure. And if they're equal to each other, it means that they are. Mm-hmm. 4 years. Mm-hmm. That's just doing this a lot. Now, again, this proof stuff, we're showing it so that y'all can see kind of the logic behind it. We're not expecting you, me or Miss Kendall, neither one of us is expecting y'all to be masters at this by the end of this chapter. Now, my undergrad did a lot more of this, so I've gotten a little more comfortable with this than the average person. So hopefully you'll at least get a little bit of this on the tests. There will be a portion with proofs, but it's not going to be like 13 and 14 was last night. It's going to be more like 3 and 4, or like this one here, where we give you part. I will give you part of the steps. You're going to fill the rest in. There is one part of the proofs that I will have completely blank, but that's the algebra proofs. So what we did in 2-4, where you solved it and put the steps, I'm leaving that blank so that y'all can actually do which steps you want to do in what order. Yes, I apparently had it in backwards or upside down when it printed. And I think it was like that last year too. Okay, so let's look at this here. So we want to write a flowchart proof, so we have this here. Given that angle 1 and 2 are supplementary and angles 1 and 3 are supplementary, we want to show that angle 1 or angle 2 is congruent to angle 3. So what do we know for sure? 1 and 2 are supplementary. Which is? We also know that, yeah, it's going to skip to this there. So we have this here. Now, it's also going to say that 1 and 3 are supplementary. Given. Now with flowchart proofs, what we're doing is what flows from one to the next. Because the reason they skip this second one is because if we know 1 and 2 are supplementary angles do what? 180 degrees, yes? So that's what that second one is that angle 1, the measure of angle 1 plus the measure of angle 2 is 180. And we know that because supplementary angles. We can put DEF of supplementary angles. We can kind of abbreviate some of this. You don't have to write the whole thing out. But if that's true, what about the measure of angle 1 and 3? Angle 3 is going to be yes. So we do know where the ending is for this here. We know where the last step is, yes? So what's this last blank going to be? Because they told us to prove. Our proof is angle 2 is congruent to angle 3. So the last step should be, or the last bubble should be, that angle 2 is congruent to angle 3. Because that's where we're wanting to get to. Possibly, but we'll need to see what it is above. Now on the test, we should at least get the given and what we want to prove on the statement side, because that should be given to us every single time. Now, so we have two statements here that are both set to equal to 180, yes? So that means we can set them equal to each other, that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle, or measure of angle 1 plus 3. So we have the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 3. So what did we do? We took two statements and made a third, which is our transitive property of, because we're setting two equations equal. If we have our congruency symbol between our two new statements, or our new statement, it would be congruency, and we'd be talking about either angles or lines. Now here we're talking about just measures, yes? Do we have the same thing on both sides? Well, we have the measure of angle 1 on both sides, yes? Right. Because the measure, so if we talk about a measure, we're just talking about a number. It's just a value for that angle. So what we can do is we can subtract it from both sides. Because whenever we have that little m in front of it, we're talking about a measure of an angle. If we just had, say, AB plus CD is equal to AB plus DF, we don't have the line segment above it, we're talking about its length. We're just talking about a number. And if two things are equal, it means that they are congruent. So that's just the definition of congruent angles.
Addison Jones, please come to the office. Addison Jones, please come to the office.
Questions on this here? Any other questions on any of this here? Yes.
What is the last, what's the last assignment, 2 point something?
For chapter 2?
Yeah.
This one?
Is it really?
Yeah, 2.6 is the last section. It's going to be, so, most likely Tuesday. Any other questions on this here?
You said next Tuesday?
Mm-hmm.
Okay.
I'm gonna have a holding aneurysm.
Let's look at this next one here. Looking at this. Yes. Finishing this up. Mm-hmm.
Well, Friday.
Friday is review.
Down for getting the review.
Mm-hmm.
What is Thursday?
And if you need a copy of the review sheet, I have it right here.
You already have them printed out?
Mm-hmm.
Okay, I'll just get you.
Make up.
I'll just make that up.
Mm-hmm. I just abbreviated it. Okay. MUD. So, all right, guys. So the last one we're doing today, I'm splitting this into 2 days. We're going to do this one here, then we'll pick up the rest of it tomorrow. So if we look at this, we want to copy and complete. Well, we already have it copied. This here. All right, guys. Let's focus in. Yes. The assignment will be given to y'all tomorrow. So,
Why is it always
all right, guys. So let's finish this up. So we have 2 blanks here to fill in.
No.
So we want to show that angle B is congruent to angle C. So if we know that AB is perpendicular to BC, because our little upside down T is perpendicular, it means that angle B is what? This angle is going to be what? So the measure of angle B is We can write it above it.
And then the last one's like congruency.
And the measure of angle C, yes, is equal to 90 degrees.
So it's like definition of segment congruent.
Definition of congruent. What are we talking about?
Angles.
Yeah. Because we can say that both of the angles are 90 degrees, so that means they're congruent to each other. I mean, we could have said instead of measure of angle B equals 90, measure of angle C is equal to 90. We can say that they're equal to each other and then go congruent.